Are we automatic processing machines? While you are watching this video, your brain receives all kinds of signals. For example, the shapes that you see on the screen, and the sounds that you hear from the speakers. The question is, does your brain process all these signals automatically? With the following experiment, we will find out. This experiment consists of several tasks. 3 of those will be explained. Every task consists of hundreds of trials, and during each trial, the participant has to push a button. During the trials, the spoken words left and right will be presented from a speaker located on the left or right side of the participant. There are conflict trials and no conflict trials. During conflict trials, there is a conflict between the content of the sound and the location of the sound.
Right. Left.
So in this case, the word right comes from the left side, or the word left comes from the right side. During no conflict trials, there is no conflict.
Right. Left.
So the word right comes from the right side, or the word left comes from the left side. During the first task, the participant has to push the left button as fast as possible when he hears the word left, and the right button when he hears the word right. During all tasks, the brain activity is measured by using EEG.
Right.
This was a conflict trial because the word right came from the left speaker.
Right.
This was a no conflict trial because the word right came from the right speaker. The participant performs hundreds of such trials. Conflict trials and no conflict trials are randomly alternated. This graph from the paper shows an analysis of the EEG data during conflict trials of task 1. The red line shows if the brain notices the identity of the word. The blue line shows if the brain notices from which side the sound came. The green line shows if the brain combines the content of the sound and the location of the sound and detects a conflict between those two features. The first dots on the lines show the result of this task. All 3 lines have a relatively high value at this point. This means that both content and location of the sound are processed and also that the conflict is detected. This data leads to the conclusion that there is a simple processing in the brain during the task, because the single features of the sound, namely the content and the location, are processed. There is even complex processing, since the brain also combines these single features in order to detect the conflict. Next, the authors went on to test other situations. What happens, for example, if participants respond to the volume of the sound, which has nothing to do with its content, location, or the conflict? During task 2, the participant has one button in front of them and has to push it when the volume of the sound is lower compared to the other trials.
Right. Left. Left.
This was a conflict trial, because the participant had to push the button when the word left came from the right side.
Right. Right.
This was a no conflict trial, because the participant had to push the button when the word right came from the right side. For the results of this task, we have to look at the dots above VO. Analysis of the EEG data shows that the red and blue lines are relatively high during this task, meaning that the brain still processes location and the content of the sound. However, the point in the green line is much lower compared to the first task. This means that the conflict can still be observed in the EEG data, but that the effect is less strong. This leads to the conclusion that there is simple processing in the brain because the content and the location of the sound are processed, but the more complex processing, namely the detection of conflict, is weakened. Now, what happens if the participant does not have to respond to the sound at all? During task 3, the participant does not respond to the sound, but only responds to dots on a screen. When they see more dots moving up than down, they push the upper button as fast as possible. And when they see more dots moving down than up, they push the lower button as fast as possible.
Left.
This was a no conflict trial because, during the time that the dots were presented on the screen, the word left was sent from the left speaker.
Left.
This was a conflict trial because the word left was sent from the right speaker. For the results of this task, we have to look at the dots that are most to the right. The red and the blue line are almost as high as during the first task, while the green line dropped to 0. This indicates that the location and the content of the sound are still processed, but that the conflict is not detected. We can even take a look at some behavioural data. This figure shows the reaction time, left part, and error rate, right part. It indicates with grey bars the differences between the conflict and the no conflict trials. For the first task, there is a significant effect on both measures, meaning that the conflict is detected. Because if the participant did not notice the conflict, there is no reason why they would have a larger reaction time and error rate on the conflict trials. But if we now go back to the results of task 3, it can be seen that there is no significant difference between the conflict versus the no conflict trials. So even according to this data, the conflict is not detected. This leads to the conclusion that only simple processing of the sound is present, but no complex processing. Now we have explained the 3 tasks and the results, we can summarize the conclusions and ultimately can answer the question that we asked ourselves in the beginning. During all 3 tasks, there was simple processing, meaning that the content and the location of the sound was noticed. During the first task, there was even complex processing, meaning that the conflict was detected. During the second task, complex processing was weakened but still present, and during the third task, it was absent. This experiment leads to the conclusion that the brain detects conflict only when the sound itself is relevant for the task. When the sound is not relevant for the task at all, like in task 3, there is only simple processing of the single features of the sound. So, are we machines that process all signals around us fully automatically? Not really. The brain indeed processes some signals automatically, but whether there is complex processing depends on the goals we have. Are you interested in more details on this research? Scan the QR code or click the link in the description. Do you want to know more about the other research of the Conscious Brain Lab? Go to consciousbrainlab.com. Video by Josella.nl.